On this video, we're going to talk about the principal methods as well as the different types of distillation processes that you will be encountering in studying chemical engineering. Well, it is very important to understand these different types of distillation processes because it is being used in different applications. So you will be encountering some problems in which a specific type of distillation process is used. So you have to approach your solution accordingly. Okay, so in practice, there are two principal methods of distillation. As you can see dito sa ating screen, we have distillation without reflux and the distillation with reflux. So dito sa ating first method, as you can see, this is based dito sa production ng ating vapor by boiling yung ating liquid mixture. In this case, we are using steam as a source of our heat. And then, yung mga vapor natin is condensed and collected dito sa ating receiver. Now, ano yung pinagkaiba niya dito sa ating distillation with reflux? So, basically, what's happening here is that here in our still, our vapor will pass through this path and will be condensed, no? Meron tayong condenser dito. And then, it is collected dito sa ating receiver. And we call this as the reflux drum. Now, the difference between these two is that dito sa ating first method, kinolek lang natin yung ating na-condense na vapor or our distillate dito sa ating receiver. While in here, kung makikita ninyo, yung nakolekta natin na na-condense na vapor is split into two paths. One is collected as the distillate, while the other is returned to our still as a reflux. Okay, so yan yung pinagkaiba ng ating dalawang process, no? So dito, after condensation, okay, we will just going to receive it here and collected, and this is what we call our distillate. While in here, we will be collecting the distillate, but part of that is returned dito sa ating still, okay? So as you can see, in distillation with reflux, it is based on the return of part of the condensate to the still under such conditions that this returning liquid is brought into intimate contact with the vapors on their way to the condenser. Okay, so yan yung principal methods of distillation natin. No? Dalawa lang naman yung tatandaan natin. Yung isa is without reflux, meaning walang bumabalik dito sa ating column. And the other is with reflux, kung saan part of our condensed vapor na nakolek natin dito sa ating receiver is returned to our still. Okay? Now, we're going to talk about the different types of distillation processes, starting with the simple batch or differential distillation. So, what is a simple batch or differential distillation? So, we have an illustration right here where this is our initial condition and this is our final condition. The simple batch or differential distillation involves batch vaporization of the liquid in a distilling still until a certain amount of the feed is converted to distillate. The liquid left in the still is called the residue. Okay, so let us analyze itong ating initial stage, no? So as you can see, meron tayo dito ng liquid mixture and we are heating it. Meron tayong heating coil dito, no? And then of course, yung more volatile component natin will vaporize. And it will come to the second stage kung saan nag-condense din itong ating mga vapor and then we collected our distillate. Okay, so katulad nung nakita natin sa previous part natin, no, in this type of production, there is no reflux. So lahat ng nakolekta nating vapor na na-condense is collected in here sa ating receiver. And then yung less volatile component natin will remain at the bottom of our still. And this is what we call our residue, okay? So this is our residue and this is our distillate. Alright, so I hope we are clear with that. So this is our simple batch or differential distillation. So this is batch process because we are processing a specific amount of our mixture and then walang pumasok or lumabas na additional na amount ng ating mixture while we are conducting our process, no? Alright, so ano naman itong tinatawag nating equilibrium or flash distillation? Well, in here, the feed is continuously heated where the potential vapor is allowed to be in intimate contact with the liquid at a certain temperature and pressure. Okay, so we have our feed in here, and it passes through this coil here, and this is our heater, no? So it's being heated on these parts. And of course, kapag hinihit natin yung ating mixture, magbe-vaporize na yung ating more volatile component. And then the mixture is allowed to pass through the pressure relief valve to separate the vapor from the liquid. So this is our pressure reducing valve. Then after that, our mixture of vapor and liquid will pass dito sa ating vapor separator. Then of course, our vapor will be passing here dito sa taas, and our liquid will be passing dito sa ating bottom. So the vapor is subsequently condensed to generate the distillate. So we have a condenser in here. Same lang nandito. Now we have a condenser here, and our distillate will be collected. While dito naman sa part ng ating liquid, the liquid is withdrawn from the separating steel as the bottom's product. Okay, so yan naman yung ating equilibrium or flash distillation. So again, yung feed natin is pinasok natin dito and allowed to be heated dito sa ating heater, and then it will be separated dito sa ating vapor separator. Yung mga liquid natin will be collected in the bottoms, and our vapor will be condensed, forming our distillate. Okay, so in here, makikita na ninyo yung kaibahan ng simple batch or differential distillation dito sa equilibrium or flash distillation. And then as we go further dito sa ating discussion, makikita natin the different approach that we will be using whenever we are dealing with different types of distillation processes. For example, dito sa simple batch differential distillation, we generally apply yung Rayleigh equation natin, ano? So our Rayleigh equation is ln of feed over W, which is our residue, yung pinag-usapan natin dito kanina. And this will be equal to the integral from XW, so nakita na natin yan, no? Yung fraction ng ating more volatile component sa ating residue to our XF. So, yung XF natin dito is this one. Yung fraction ng ating more volatile component in our feed. And then, this is the integral of dx over y minus x. Okay, so we will be discussing about Rayleigh equation when we reach to simple batch or differential distillation. While dito naman sa equilibrium or flash distillation, then we can do an algebraic method of solving this. So we'll just do material balance here. So we have F to our feed, we have B, okay, to our bottoms dito sa ating liquid, and D to our distillate. So after condensation, ano? Okay, so therefore for our overall material balance, we have feed is equal to B plus D. Okay, then for the more volatile component balance, we have F XF is equal to B XB plus D Y D, no? So this is what we are going to use when we have flash distillation. But we will also be using graphical method, okay, in solving for this, kung saan gagamit tayo ng ating equilibrium diagrams na natutunan natin sa ating previous lectures. Alright, so another type of distillation process is yung simple continuous distillation process, no? So basically, this is the same as the batch distillation, no? Itong nandito kanina, no? So what is the difference? Ang pinagkaiba lang is that a certain feed is introduced continuously in the distilling still, and the product is also withdrawn continuously as the solution is vaporized to generate the distillate. Okay, so sa batch process natin, meron na tayong specific amount ng ating mixture, no? So, while the process is ongoing, walang pumapasok or lumalabas na amount ng ating liquid mixture dito sa ating still. Okay, so walang nadadagdag at walang nababawas sa ating liquid mixture. But in this case, no, sa ating simple continuous distillation, yung feed natin is continuous na pumapasok dito sa ating distillation unit. And then continuous din tayong kumukuha ng distillate and bottoms product. Okay? Now, at steady state, the amount and concentration of liquid in the still is maintained constant all throughout the operation. And to relate the distillate and bottoms product, we assume that these are in equilibrium, so the relative volatility can be used. And we will talk more about that in a separate video about simple continuous distillation process. Now, we have what we call steam distillation process. So, meron tayong example diagram here. And this is, as you can see, an example kung saan we have a product here which is an essential oil because usually ginagamit yung steam distillation sa pag-i-extract ng oil. So, this involves the separation of volatile component which is not miscible in water from a non-volatile impurity by allowing steam to flow directly through the mixture. Okay, so have a look at our figure in here. Ito yung ating liquid mixture. And then we are introducing steam dito, no, sa part na to dito sa ating illustration. Now, when we use steam, we will be heating up itong ating liquid mixture in here. And because of that, our more volatile component will start to vaporize. So, magkasama yung ating steam at yung ating more volatile component vapor dito sa pot na to. So, yung lalabas nating vapor dito is consist of our vapor from our mixture and our steam. And then, may iwan naman dito yung ating less volatile component or the non-volatile impurity dito sa ating liquid mixture. So, dahil dalawa yung naandito sa ating pot dito, we have the steam and we have our more volatile component. So, kapag nag-condense tayo dito, dalawa rin of course yung makukuha natin. Yung ating more volatile component and our steam. That is why we mentioned here that our volatile component is not miscible in water. Okay, because after the condensation process, okay, magli-liquefy yung ating steam. We have water in here and we have our more volatile component condensed na nandito. In this case, we have essential oil. And dahil immiscible sila, so magkakahiwalay sila, no? Meron tayong separation dito. So, we will be collecting yung ating condensed water, which is at the bottom. And yung nasa top naman nating oil will be collected as well. Okay? So, that is why we mentioned here, the steam carries some of the volatile components to the vapor phase, no? Dito yon. After heating, magbe-vaporize yung ating more volatile component. So, magkasama sila ng steam natin dito. So, this vapor is cooled and condensed into two different liquid fractions. So, sometimes, the fractions are collected separately or they'll have different density values in order that they separate on their own. So, as you can see here, since they have different density values and they are completely immiscible, so we can separate that easily from our receiving vessel. So, this is how our steam distillation process works. And then our last type of distillation process is our fractional distillation or rectification. So, this is the second principal method of our distillation process dahil meron tayong reflux. So, in order to get high product concentrations, fractional distillation is applied. It is employed when the boiling points of the components of a mix are near to each other as determined using Rolle's law. Now, it involves sequence of stages where there is intimate contact between the liquid. At a lower temperature, coming from the top of the column with the vapor, at higher temperature flowing from the bottom. Well, this contact results in the exchange of more volatile component from the liquid to the vapor and less volatile component from the vapor to the liquid. Now, by continuous contact, the more volatile component of the vapor increases as it flows from stage to stage until it goes through the condenser, where the condensed product is split into reflux and distillate product. So, this is what we can see here in our illustration in here. Okay, so katulad ng sinabi natin kanina, we have series of stages here in our rectification, no? Or fractional distillation. So similarly, the less volatile component of the liquid increases at it flows from stage to the bottom. So pababa naman siya, where it goes to the reboiler. Ito naman yung reboiler natin, okay, sa ating illustration for rectification. Ano? Now, Here are the common challenges to chemical engineers in order to design the plates and distillation column. So this is usually what we will be encountering when we are designing a distillation column. So one typical problem is to determine the number of stages that we need para sa ating distillation column. Then another thing is to determine the heat requirement and relate the flow rates of the products and the internal flow rates of the vapor and liquid. So we will be talking more about these types of distillation processes as we proceed in our study. So we will be discussing this in separate videos para mas ma-explain natin sila further. So what we want here on this video is to provide information, an overview sa mga distillation processes natin para meron na kayong idea how the distillation process operates kapag sinabing, let's say, we have a steam distillation process or a flash distillation process. So you can easily visualize kung ano yung possible na nangyayari dito sa ating process, no? So on our separate video, we will be talking more about each of these distillation processes and we will be solving some problems para mas maintindihan natin siya. So with all of that and more, I will see you in our next video.